Hello everyone. Today in this video we'll discuss about the interrupt handlers and importance of the interrupt handlers and role of the interrupt handlers in the computing model world. Okay, interrupt handlers and interrupt handler or else ISR is invoked by the operating system when an interrupt occurs. It saves the current CPU state, handles the specific interrupt task, and then restores the CPU state to resume normal operations. Types of interrupt handlers includes hardware interrupt handlers for device signals and software interrupt handlers for system calls or exceptions. So this is a diagram of an interrupt handler. So as we can see, there are instruction 1, 2, 3. So this is a user program. So if there are any interrupt which is occur between the program, so it is sent through the instruction which is the interrupt handler, and the interrupt which sends the output through here to the interjunction I plus 1. So the code is divided into a few lines or else a few kind of steps. So instruction 1, 2, 3 are the instructions which are passed during the code. So instruction 1 has some interrupt, so which is sent through the interrupter, and the interrupter sends the output which is called the instruction I plus 1. So this is the updated version of the particular instruction. So the operating system handles interrupts by pausing the current CPU task. So when the interrupter is sent the code or else something program, so it stops the current working CPU task to work on this particular interrupt, save its state and executing an interrupt service routine ISR, which is called as interrupt service routine, to address the interrupt. After processing, it restores the CPU state and resume the interrupted task. This mechanism ensures timely response to hardware and software events. Interrupt in an operating system are managed through a structured process to ensure timely and efficient handling of the events. So these are some of the things which are used in the interrupt handler process, which is the interrupt request, interrupt controller, interrupt vector table, context switching, execution of ISR, and resuming execution. The IRQ, which is nothing but interrupt request, and interrupt request is generated by the hardware or software. So this is a request in this diagram which is generated by the program, user program. The interrupt controller prioritizes interrupt and sends them to the CPU. So this interrupt handler is present in the CPU, and the interrupt is sent through the CPU. Interrupt vector table. This table maps each interrupt to its corresponding interrupt handler or else interrupt service routine. So as we can see in a particular interrupt or else in a particular error, so the CPU or else the vector table divides the interrupts according to their particular um, head, or else the cause which has it has arisen. So it might be the hardware, so it might be the software. So this table distinguishes the interrupts between their particular frames. Context switching. The CPU saves its current state and jumps to the ISR associated with the interrupt. So when an is arrived, the CPU stops its particular or else the running state, and it goes to the interrupter method. Execution of ISR. The ISR perform necessary actions which may involve interacting with the hardware or executing specific software tasks. Resuming execution. After completion the ISR, the CPU restores its previous state and resumes the interrupted program. As the time of the interruption, the CPU stops its working on the particular program or this particular thing. So it goes to the interpreter and it takes the information from that and it retrieves the ongoing process. So as we can see, this is the software interrupt, and this is the hardware interrupt. The kernel IRQ interrupt handler. So this is the interrupt handler for this. Uh, so this is a device interrupt controller. So this is an interrupt controller. If the so in the hardware, if the device has an arise any interrupt, it goes to the interrupt controller and then to the CPU. If in case of the software, it might be any program, it might be any software softwares or else apps which give interrupts. So it goes to the interrupt handler and gives back to the original ongoing process. The role of an interrupt handler or else interrupt service. The interrupt handler, also known as the interrupt service routine, plays a crucial role in the operating system response to interrupt. Here are some key responsibilities: interrupt recognition response, context prevention, interrupt handling, priority management, context restoration and resumption, error handling. The IS are responsible for recognizing incoming interrupts from various sources, such as it might be a hardware or a software generated signals. Context prevention: before handling the interrupt, the ISR saves the current state, or else the ongoing process. This includes saving the program counter registers and other relevant information which are necessary to resume after the execution. Interrupt handling: once the ISR starts, it executes tasks specific to interrupt types, such as data management flow with the hardware device, or else addressing the software triggered events like system calls or errors, ensuring the timely and appropriate handling for each interrupt scenarios. Priority management: ISRs are typically prioritized to ensure that critical interrupts are handled promptly. They may temporarily suspend lower priority tasks to address higher priority interrupt efficiently. Context restoration and resumption: after completion the necessary operations related to the interrupts, the ISR restores the saved context from the interrupt process. This allows the process to resume execution seamlessly from where it has halted. Error handling: ISR often includes mechanisms to handle exemption conditions such as error interrupts or faults. They may log errors, initiate recovery procedures, or alert the operating system to take appropriate actions. Importance of an application of interrupts. The application of an interrupts plays a crucial role at the time of the errors. So these are some of the reasons why these interrupts are so important. If efficiency and responsiveness: interrupt streamlines CPU utilization by allowing it to handle diverse tasks concurrently, optimizing multitasking and ensuring timely processing of critical inputs and peripheral data. Real-time responsiveness: interrupt ensures immediate response to crucial events in system like industrial controls and network routers, maintaining stability, reliability, and high performance operations. Resource management: interrupt enables efficient hardware resource usage by signaling device into initiate or complete operation, reducing latency in the data handling and enhancing overall system efficiency. Event driven programming: interrupt supports event driven software where responses to asynchronous events such as user input or network packets occurs instantly, conversing CPU resources and simplifying program architectures. Error handling and exception management: interrupts manage errors and exceptions effectively by triggering responses such as error logging, administrative notifications, or corrective actions, ensuring system integrating and minimizing downtime. So these are some particular reasons why the application of interrupts are that much important. So this plays a crucial role. It might be in the network, it might be the industries, it might be any kind of organization. Application of interruption: so these are the some of the places or else in the real world applications where the uh, interrupts are used. Embedded system: interrupts manage real time events like sensor inputs or network communications in the embedded devices. User input handling: they facilitate immediate response to user actions such as keyboard input or mouse click in the graphical user interface. Device drivers: interrupts are used extensively in the device drivers to manage communication between hardware, peripheral, and operating systems. So these are some of the real world cases where the interrupt are used and are very much required to stop the interrupts. So, so we have discussed a few topics about the interrupts, the roles of the interrupt and the classification of the interrupts, and its importance of the application of the interrupts in the real world as well. There are some steps as well which we have discussed in this video. So, what are the steps which are used at the time of interrupts? So, thank you so much.